Find the equation of the plane that passes through A, 1, 2, 1, B, -2, -1, 4, and C, 2, 1, -2. Firstly, as a vector equation in parametric form. So what we have is a plane where A, B, and C are points in the plane. We could use any of those points to get onto the plane. I'm going to use A. So here's our vector A. And so I've got R is equal to 1, 2, 1, and that gets me onto the plane. Vectors that are parallel to the plane would be this vector B and this vector C. Now the vector B there is going to be -2, -1, 4, take away 1, 2, 1. Remember, this vector B goes from A to B, and if we have A to B, we use the turnaround rule, B minus A. So that's going to give me -3, -3, 3. So we can have lambda -3, -3, 3. You could cut this down to -1, -1, 1, just dividing by 3. And then we want the vector C, which is going to be 2, 1, -2, take away 1, 2, 1, and that is the vector 1, -1, -3. So we've got 1, -1, -3 times mu. As I say, we could simplify that one. 1, 2, 1 plus lambda -1, -1, 1. And if you wanted to only have one of them being negative, you could make that 1, 1, -1 if you wanted to. And then you've got mu 1, -1, -3. Strictly speaking, we ought to change the lambda to something else, but it doesn't really matter. As long as you end up with this answer or something equivalent to it, it would be fine. We now want a vector equation in scalar product form, and that means that we need a normal to the plane, and we can use these two vectors to find that. So we're going to do a cross product. ijk, -1, -1, 1, 1, -1, -3. And let's see what that gives us. So remember, when we're doing this, we have to cover up the ijk. And to start with, we cover up the I. And if we do that, we're going to get 3, take away -1. And so that will be 4. We'll then cover up the j. And we're going to get 3, take away 1, which is 2, but remember we changed the sign on the middle one. And then we cover up the k, and that's going to give us 1, take away -1, so that will be 2. And then we could use as our normal, if we want to, we could use 2, -1, 1, and use that one as our normal. And so we have r dot 2, -1, 1 would be equal to a point we know is on the plane, so we could use the 1, 2, 1 for that. So 1, 2, 1 dot 2, -1, 1, and that's going to give me 2, take away 2 plus 1, so that will be equal to 1. Then finally, the conversion into Cartesian form. we know that we use the normal here as the coefficients, so I've got 2x minus y plus z equals 1